Imagine you're flying in a spaceship, far from Earth. There's no sound. No light. Nothing but distant stars. Everything is calm, until you notice something strange. A faraway star begins to warp, its light pulled toward a dark point in space. Gases spiral at insane speeds around, nothing. It's as if some invisible force is dragging the universe into itself. What is this unseen thing? But it is stronger than anything we know. Is it a hole in space? The end of the world? Or just the laws of nature taken to the extreme? I think you discovered what I'm talking about. And this is not because you are intelligent, it is the title of the video. This thing is the black hole. But here's the twist. The name is misleading. It's not really a hole, and it's not black in the way you might think. A black hole is simply a massive amount of matter squeezed into an incredibly small space. And when I say massive, I mean it. We're talking about something heavier than our sun by tens, hundreds, even thousands of times, maybe more. All of that mass crushed into a tiny point. Imagine squeezing the sun into a ball the size of a city, or even smaller. At that point, gravity becomes so strong that nothing escapes. Not a moon. Not a spaceship. Not even light. That's why we call it black, because no light escapes. And hole? That's just a figure of speech. If you could reach one, you'd find an object with real mass, not an empty pit floating in space. So, how do black holes form? Let's start with stars. Stars aren't just glowing balls in the sky. They're giant nuclear engines. Inside, hydrogen atoms fuse into helium, releasing incredible amounts of energy. That's what keeps them shining for millions, or even billions of years. But fuel doesn't last forever. When it runs out, the fusion stops, and the outward pressure disappears. Then gravity takes over, pulling the star in on itself. If it's small, like our sun, it collapses into something called a white dwarf. But if it's huge, more than 8 times the mass of the sun, the collapse is far more violent. The star explodes as a supernova, leaving behind a dense core. If that core is heavier than 3 suns, not electrons, not neutrons, not any known force, can resist gravity's pull. The collapse continues until the matter is squeezed into an infinitely small point. And just like that, a black hole is born. Now, I have to answer your smart question that came to your mind. How did scientists even know about black holes before they ever saw one? The idea started over 200 years ago. In the late 1700s, a man named John Michel asked himself, what if there's a star so massive that even light can't escape it? He wrote it down, and history forgot about it. Until a young man in a small office in Switzerland came along. No lab, no fancy equipment, just paper, a pen, and a mind full of questions. That man was Albert Einstein. In 1915, he introduced his groundbreaking theory, general relativity. He explained that gravity isn't a force pulling objects, it's the bending of spacetime caused by mass. Imagine space as a stretched rubber sheet. Place a ball on it, it sinks, making a curve. Anything near it moves along that curve, not because it's pulled, but because it's falling into the bend. The Earth bends spacetime, and Moon follows that curve, orbiting it. Now, what if you put something incredibly massive on that sheet? And then, squeezed it smaller and smaller? The curve would become so deep that, at a certain point, there's no way out. Cross that line, and you're gone. You, light and everything. That line is called the event horizon. Soon after Einstein's equations were published, a scientist named Karl Schwarzschild solved them and wrote to Einstein. According to your equations, there's something with infinite density. But Einstein thought it is just a mathematical result and didn't believe it could exist in reality. He thought nature would somehow prevent it. As it turns out, the universe doesn't care what we think is impossible. For decades, black holes were just theory. Then in the 1960s and 70s, astronomers noticed strange things in space. For example, in the constellation Cygnus, a huge star orbits something invisible. Calculations show the hidden object has more than 5 times the sun's mass. Too heavy to be a neutron star. So, what do you think it is? Good job. It is a black hole. I know what you are thinking about now. How do we detect something we can't see? Your focus is high today. Actually, we can't see black hole, but we can see its effects. A black hole can steal gas from nearby stars. That gas doesn't fall straight in, it swirls at incredible speeds, forming a superheated disk. As it spins, it heats up to millions of degrees and blasts out X-rays. Telescopes can detect those X-rays. We don't see the black hole itself. We see the meal it's cooking. Over the technology revealed dozens of small black holes formed from collapsed stars. But then, something bigger has been discovered. At the center of most galaxies, there is a supermassive black hole. In the middle of our own Milky Way, there's one about 4 million times the mass of the Sun. How did it form? We're not sure. Maybe it started small and grew by swallowing stars and gas. Maybe it formed directly from dense clouds in the early universe. And they're not just cosmic monsters. They help shape entire galaxies. When a black hole swallows too much matter, it shoots out powerful jets, columns of plasma moving near the speed of light. These jets stretch for thousands of light years, heating surrounding gas and stopping new stars from forming. Black holes don't just destro. They regulate. Without them, galaxies might not look the way they do. In 2019, history was made. A global team of scientists connected telescopes all over the world and focused on a distant galaxy. After months of work, the image appeared. A glowing ring surrounding a dark center. It was the first ever real image of a black hole's shadow. The ring was light bent around the event horizon. The dark center was the point of no return. Now, imagine jumping into one. As you approach, time slows down. From far away, someone watching you would see you slow to a crawl, and then freeze at the event horizon. But from your perspective, you keep falling normally. Closer in, the difference in gravity between your feet and head becomes extreme. Your feet are pulled harder than your head. You stretch and stretch until you become a long, thin strand. Scientists call this spaghettification. Yes, it's a real term in physics. And it is not because they like pasta, it is because you become like spaghetti. But, do black holes live forever? In the 1970s, Stephen Hawking made a shocking claim. Black holes slowly lose mass and could eventually vanish. This is called Hawking radiation. Here's how. Quantum mechanics says empty space isn't truly empty, pairs of particles constantly appear and disappear. Near the event horizon, one particle might fall in while the other escapes. From outside, it looks like the black hole is shrinking. A black hole with the Sun's mass would take more than a billion years to evaporate. Far longer than the universe has existed. So, don't worry, they won't evaporate soon. Let's clear up some myths. Black holes suck up everything like a vacuum cleaner. This is wrong. Their gravity is only dangerous if you get close. If the Sun were replaced with a black hole of the same mass, Earth's orbit wouldn't change. Falling into one takes you to another universe. No evidence. Wormholes exist in theory but are unstable and uncrossable. They're a threat to us. The nearest is 1,500 light-years away. No danger. But the real danger is that there are no signs in space saying, "Warning, black hole ahead." We all have the same question now. Why do we care about them at all if they're so far away? Because they are natural laboratories, testing the laws of physics under extreme conditions. They might even help us merge Einstein's relativity with quantum mechanics. One big mystery is the black hole information paradox. If information falls in, is the information lost forever? If not, where does it go? Solving this could change our understanding of spacetime itself. In the end, black holes remind us of three important things. The universe doesn't care about what we think is reasonable. And reality is stranger than fiction. And the final and most important thing. Darkness isn't always emptiness, sometimes, it's the beginning of everything. Thank you for joining me on this journey into the heart of darkness. Now that you're back safe, you know what to do: like, subscribe, and hit the bell. I'll see you on the next trip. Who knows? Maybe to wormholes or parallel universes. Why not?